In this video, I'm going to demonstrate 3 different methods for finding the distance between 2 points. Firstly, when we have either a horizontal or a vertical line, we can simply just count the unit squares between the points. So for example, the length of both these line segments would be 6 units. The length of a line segment, or the distance between 2 points, can also be found using Pythagoras' theorem. The line segment, or the distance between A and B, is the hypotenuse of a right-angled triangle. We then create the right-angled triangle from this line segment. Find the length of the shorter sides by counting the squares on the number plane. Pythagoras' theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the shorter 2 sides, or this translates to the formula c squared is equal to a squared plus b squared. In this example, ab squared is equal to 4 squared plus 4 squared. If we simplify this down, we get ab is equal to the square root of 32, so the length of the line segment AB is equal to 5.66 units. Our third method is using the distance formula. This formula is best used when you are just listed 2 points rather than having them plotted on a number plane. So in this example, let's find the distance between the points -1, 3 and 2, 1. So as you can see in the formula, we need an x1, a y1, an x2, and a y2 value. So let's call the point -1, 3, point 1, and the point 2, 1, point 2. Therefore, -1 becomes our x1 value, 3 becomes our y1 value, 2 becomes our x2 value, and 1 becomes our y2 value. So the distance is equal to the square root of 2 minus -1 all squared plus 1 minus 3 all squared. This is equal to the square root of 3 squared plus -2 squared, which is equal to the square root of 9 plus 4, which equals the square root of 13. This means that the distance between the points -1, 3 and 2, 1 is 3.61 units.